Hello students, this video intends to help aid in your understanding of confounding variables as well as the differences between correlation and causation as they are presented in the Stat 1040 and 1045 classes. Within this video, we will touch on objectives 1.6 and 1.7 of Unit 1. We will be covering the concepts shown on screen. After some explanation, you will have a chance to practice these concepts at the end of the video. Let's get started. We will begin by exploring the concept of confounding factors, including building an understanding of what they are, as well as looking at some examples. A confounding factor is defined as being an extra variable, besides the ones being specifically looked at in the study, which can influence the results. A confounding factor can be anything which creates a difference between the control and treatment groups, besides the treatment being imposed. As a consequence of this, the presence of a confounding factor can lead to inappropriate or leading results that can skew researchers' understanding of how two variables relate to each other. A well-designed experiment controls for confounding factors by randomizing subjects into the control and treatment groups. Randomization further reduces human bias and allows for the composition of the two groups to be as objective as possible. To improve our understanding of recognizing confounding variables, let's talk through an example. A researcher graphs the amount of money gained from ice cream sales and the frequency of shark attacks along the West Coast, and finds that the two variables are positively associated. Just looking at this data, we can see that the more people buy ice cream, it seems like they are at a higher risk of getting attacked by a shark. However, there are confounding factors at play here which contribute to the relationship's existence. For instance, ice cream is likely to be sold more when it is hot outside. When it is hot outside, people are more likely to go swimming at the beach. When more people are swimming in an ocean, it is more likely that a shark attack could occur since there are more bodies in the water in the first place. As you can see, it is important to be wary of the existence of confounding variables and keep an eye out for them before you try to imply any sort of correlations or causations. Speaking of which, let's now turn our attention towards understanding the differences between correlation and causation as they relate to studies and experiments. Correlation is a term which refers to a relationship between two variables, as revealed through a study or experiment. Correlations can reveal insights about how one variable may be related to another, but no definite conclusions can be derived from correlations. Correlations can be positive or negative, which indicates how the x and y variables respond to each other. In a positive correlation, as the x variable increases, the y variable also increases. In a negative correlation, as the x variable increases, the y variable decreases. An example of a correlation would be where an observational study finds that there is a positive association between time spent studying and percent grade in the class. This means that as time spent studying increases, the percent grade likewise increases. However, since this is only an observational study, we cannot state that spending more time studying causes you to have a higher grade. Causation, on the other hand, is a term which refers to the cause and effect relationship between two variables, as revealed only through well-designed, controlled experiments. An example of a causal relationship would be if a randomized controlled study collected data indicating that there was a positive relationship between UV light exposure and DNA replication errors. There is a positive correlation between these two variables. But since the data also comes from a controlled experiment, we can imply that greater exposure to UV light causes increased errors in DNA replication. Now that we have built upon our understanding of confounding, correlation, and causation, let's utilize our knowledge of these concepts by doing some practice. A 2019 study in Italy followed more than 22,000 people for several years. They asked people how many meals they ate each week containing chili powder, and found that those who ate food flavored with chili powder 4 times a week had a lower risk of death than those who never ate chili powder. Question 1. Given the findings of this study, can we state that if you eat food flavored with chili powder, then you will have a longer lifespan? Pause to answer and then press play to check your work. Answer: no, stating this would imply a causal relationship. While a correlation does exist here, since this is an observational study, we can only demonstrate the association between chili powder and lifespan, rather than imply that eating more or less chili powder causes you to live shorter or longer. We are able to pick up on the fact that this is an observational, longitudinal study, since the problem mentions that there were 22,000 Italians followed over a period of several years. There is no mention of a random assignment to any sort of treatment or control group, and therefore this is not a controlled experiment. To reiterate, we cannot possibly derive any sort of causal relationship from observational studies. Question 2. In Italy, the lower class is more likely to eat dishes with chili powder. Likewise, the lower class has increased rates of death. Can we state that socioeconomic status appears to be a confounding factor in the study? Pause to answer and then press play to check your work. Answer: no, socioeconomic status is not a confounding factor in this specific study. Our study states that more chili powder consumed is correlated with longer lifespan. Question 2 insinuates that due to class, more chili powder is correlated with lesser lifespan. The data does not support the findings, and therefore we can rule out socioeconomic status as a confounding factor here. Question 3. In Italy, chili powder is most commonly used to flavor dishes which heavily feature vegetables. Can we state that vegetable consumption is a confounding factor in this study? Pause to answer and then press play to check your work. Answer: yes, we can argue that it is the increased intake of vegetables that contributes to a longer lifespan, rather than the chili powder itself. The data is consistent with the study's findings and offers a reasonable explanation for the findings of said study. Therefore, we have identified a potential confounding factor in the study. If these or any other concepts require some more of your attention, feel free to watch this video again, reach out to your professor or recitation leader, or utilize the free tutoring services offered at the Aggie Math Learning Center. We hope this video was helpful, and remember that help is here if you need it.